Hello guys, my name is Mohammed and I'm going to do a presentation on natural gas. I will be covering the discovery, recovery, transportation, storage and distribution of natural gas in Canada. As you can see in the picture, I've chosen a blue flame to represent natural gas because for most of us our only direct experience of natural gas is the blue flame that we see on our stovetop. What is natural gas? Natural gas is a vital component of the world's supply of energy. It is one of the cleanest, safest and most useful of all energy sources. We use natural gas to heat buildings, cook food, dry clothes, heat water and even to help produce electricity. Now let's talk about the formation of natural gas. Millions of years ago, the remains of plants and animals decayed and built up in thick layers called organic material. Over millions of years, sand and salt changed to rock, covered the organic material and trapped it beneath the rock. Pressure and heat changed some of this organic material into coal, some into oil and some into natural gas. Today we drill down through layers of sand, salt and rock to reach the rock formation that contain oil and gas deposits. Methane is the lightest and simplest hydrocarbon. Natural gas is composed almost completely of methane or methane, a gas whose molecules contain 4 hydrogen atoms attached to 1 carbon atom, making the formula CH4. Natural gas has a density roughly half that of air, which means that it will rise and disperse when released into the atmosphere. Natural gas consists of 96% of methane, 0.3% of nitrogen and propane, 1.5% of ethane, 0.1 to 1.4% of other hydrocarbons. The boiling point of natural gas is minus 161 degrees Celsius. And the melting point is 182.5 degrees Celsius. Natural gas is slightly soluble in water. Natural gas is a colorless and odorless substance unless it contains the naturally occurring odor or has an odorant added. Natural gas is lighter than air and will rise and dissipate rapidly. Natural gas is neither toxic nor poisonous, but it can cause suffocation in a confined space because of its ability to displace oxygen in the blood. Natural gas will burn when mixed with air and ignited. The discovery of natural gas in Alberta was an accident that began a massive industry in Canada. In 1883, the Canadian Pacific Railway was drilling for water for its transcontinental railway that was located 55 kilometers northwest of Medicine Hat. This is the exact location of Medicine Hat. It's located south of Alberta. To the workers' surprise, gas emitted from the well. A second well a few meters away from the original site was drilled in 1884 and it was specifically searching for natural gas. This is the location where natural gas emitted, and these numbers represent storage locations. This is the picture of the first well. It was taken before the workers started to drill for water. And this picture is the location of the second well after it was drilled for natural gas. And in this picture, geologicals are trying to take soil samples to see if natural gas exists in that specific location. Now let's talk about the processing of natural gas. Natural gas as it exists underground is not exactly the same as the natural gas that comes through the pipelines to our homes and businesses. Natural gas as we use it is almost entirely methane. However, when we find natural gas underground, it comes associated with a variety of other trace compounds and gases, as well as oil and water, which must be removed. And in this chart you can see the process of removal of mercury, CO2 and water in natural gas to make it pure natural gas. Natural gas storage. Natural gas can be stored for an indefinite period of time. There are three common ways of storing natural gas: depleted gas reservoir, aquifer reservoir, and salt formation. Let's talk about depleted gas reservoir. They make use of depleted underground natural gas reservoir that contained oil or gas originally. Gas is injected back into the reservoir so as to refill the reservoir. Depleted gas reservoirs are those formations on the earth that have already been tapped of all their recoverable natural gas. This leaves an underground storage geologically capable of holding natural gas. Of the three types of underground storage facilities, depleted reservoirs are the cheapest and easiest to develop, operate, and maintain. The first instance of natural gas successfully being stored underground occurred in Wetland County, Ontario in 1950. Aquifer reservoirs are another option of storing natural gas. Aquifer reservoirs are underground and are composed of porous rock. This rock held natural gas at one time and makes a well-suited location for storing natural gas. We usually store natural gas in aquifer reservoirs that we expect to use within about a year's time. It can be time-consuming to extract the gas that we need from aquifer reservoirs, so other methods are used for gas demands that are unexpected. The last and least important method of storing natural gas is salt formation or salt caverns. These formations are well suited for natural gas storage in that salt caverns. Once formed, allow little injected natural gas to escape from the formation unless specifically extracted. The walls of a salt cavern also have the structural strength of steel, which makes it very resilient against reservoir degradation over the life of the storage. In this diagram, as you can see, letter A represents salt formation, letter C represents aquifer reservoirs, and letter D represents depleted reservoirs.
Millions of barrels of oil and millions of cubic feet of natural gas are pumped each day, but there are thousands of miles between the wellheads and where the oil and natural gas must go. Transporting enough oil and natural gas across the globe to meet the daily demand is an epic undertaking, and at each step, technology is there. On the sea, where mammoth crude oil tankers as long as the Eiffel Tower are plying the waves, it is improving safety and security and training pilots to guide them more skillfully. Under the ground, it is monitoring wear and tear on pipelines and pinpointing problems before they occur. And technology is enabling routing experts to track every one of those millions of barrels of oil or millions of feet of natural gas as they move across the globe to the next destination on their long journey.
Transportation of natural gas. Natural gas is moved by pipelines from gas plants to consumers. When chilled to very cold temperatures, natural gas is transformed into a liquid and can be stored in this form. This is liquefied natural gas, LNG, which can be loaded onto tankers and moved across the ocean to deliver gas to other countries. Once in this form, LNG takes up only 1/600 of the space that it would in its gaseous state. Once the ship reaches the destination areas, it can be shipped by truck or trailers in large chilled tanks close to users, or it can be turned back into gas to add to pipelines. Tank trucks can carry LNG or compressed natural gas (CNG) over shorter distances. Compressed natural gas or CNG is natural gas under pressure which remains clear, odorless, and non-corrosive. Although vehicles can use natural gas as either a liquid or a gas, most vehicles use the gaseous form compressed to pressures above 3,100 pounds per per square inch. Distribution of natural gas. The delivery and distribution of natural gas to its point of end use is done by a distribution company. Distribution involves making a small volume of gas at low pressures over shorter distances, and it is distributed to a large number of individual users.